this is Miss Redmond here with you guys today. So we're starting chapter 5, which is so very exciting. This is probably one of my favorite chapters of the entire workbook, by the way, and so I hope you enjoy it too. Chapter 5 is all about systems of linear equations. So we just have a few definitions to write down before we get started, because you might be asking yourself, what is systems of linear equations? So let's define that first. And this is formed by two or more linear equations that use the same variables. So for example, the common variables that we use when writing an equation would be x and y. Okay, it does not have to be x and y, it could be a and b, but most of the time you'll see x and y. So what this tells us is that these equations are related. They have the same variables, they use the same independent and dependent variable. So this is different than when we were working with scatter plots, because we took two data sets and compared them, but we didn't even know if they were related or not. Here we already know that they're related, okay? So we should see some interesting relationships between these two lines. So then we have solutions for linear equations. So I'm just going to kind of write this underneath. This is specific for linear equations. Not life, not English class, just in math about linear equations. So solutions is any ordered pair that makes the equations in the system true. So what does this mean? Makes the equations in the systems true? Basically, the same x value for both equations that you plug in gives you out the same y value for both equations. So I'll write that down. And then today, when we graph, so this is particular for graphing, our solution will be the point where the lines intersect. Okay. So there's our notes. Now let's look at some examples. So you can open your workbook to lesson 5-2, and this will be page 174 in your workbook. If you'd like to follow along, page, 274. 274, we're in volume 2 now. Okay, so let's start by looking at our first example here. So Lee is choosing a new cell phone plan. How can she use the graphs of system linear equations to determine the phone plan when the phone plans cost the same. Okay, so cost the same, what we're looking for here again is when these equations are equal to each other, or when they have the same x and y value. And because we're going to be graphing in this section to solve these equations, this is going to be the point where the line intersects, okay? So we're looking for a solution to the system of equations. Awesome. So we look at these two plans here. We see one is 20 cents per minute plus $75. So I can write my equation. Remember, we start with y is equal to mx plus b. M is the slope, or we get that from the rate. And b, this is the y-intercept, and we get this from the starting value, or you can say this is a one-time event. Okay, so quick review. So for company A, and bring it over here. So it costs 20 cents per minute. That's going to be a rate. And I'm going to say 20 cents is 0.20x. Plus the one-time event, we have to pay $75 once. So plus 75. Okay, for company B, our rate now is 25 cents per minute. And this time our one-time rate, our payment, I guess, that we have to make is $70. So now we have our two equations and we have to graph them down here. Okay, so I'm going to say for y, actually let's start with x. X is minutes used. Okay, and that determines the monthly cost. And this is in dollars. Okay, it's not in cents, it's in dollars. Okay, so now I can look back at my equations up here. So for my first one, let me do this in pink, company A. I have, let's see, a y-intercept of 75, so here I'm going by tens. So 75 would be right here. It's my y-intercept. And this 0.2, I can say this is 1/5, that rate, because in 1/5 x plus 75. Sometimes it's a little bit nicer to see my slope as a fraction. So 1/5, here I'm going to, let's say this is the same as 10 over 50, right? 1/5 is 10 over 50. This makes it a little bit easier for me just because I have such big numbers for my intervals. So now I can see, okay, I go up 10 and I go to the right 50, right? Because our slope is rise over run. So I'm going up 10 over 50, up 10 over 50, up 10 over 50. Okay, so this makes it a lot easier for myself. Because if I try going up 1/5, it's like, you don't even know where that would be on the graph. Okay, so have my ruler draw a nice straight line. Okay, so that's for company A. And then for company B, we'll do this in blue. So we start at 70 for this one. So that's 70. And this time I'm going to write this as 1/4x plus 70. And this would be the same as 10 over 40. So 10 up, 40 to the right. So 10 up, 40 to the right. 10 up, 40 to the right. 10 up, 40 to the right. 10 up, 40. Keep on. Whoa. is my marker? Right here. Oops. I'm gonna do this on pencil. That way I can make mistakes and it's not a big deal. Okay. Oh, you know what? I just realized this is I messed up. This is going by, this is 25, this is 12.5. This isn't going by tens. That's right, I'm going to pay attention to the intervals. Okay, so let's just ignore those blue values. So let's see. I'm going to just go, let's say this is you know, if I were to rewrite this as over 100, I'd be going 25 at 100 over. That actually makes it the nicest because then I can say, okay, here's going 100 over, 100 to the right, right? So when I go rise 25, okay, there we go. Okay. Sorry about that, guys. Okay. So, here is my point of intersection. Okay, they both have that point right there on the line. And that point where the two lines cross, we call this our solution, okay? So here they cross one time, we have one solution, and that solution is 195. That's that point, 195. So what this tells us is that after 100 minutes, the phone plans cost the same, and that would be $95. All right, let's look at another example. Okay, so here we have our system of equations. We have two equations. This one's nice because it's already in the slope-intercept form. We have to change this one, and we have to put it into slope-intercept form as well. So let's solve for y. So I have to start by subtracting 2x from both sides. So we have negative 2y is equal to negative 2x minus 2. Now I need to get y by itself, right? Because it's always y is equal to mx plus b. So I need to divide by negative 2. Divided here by negative 2. We get y is equal, negative 2 divided by negative 2 is just 1x. Negative 2 divided by negative 2 again, plus 1. So here's our two equations. So let me graph these. X minus 4. I'm going to change my graph real quick so it fits a little bit better. We're going to say, I'm just going to cross this out. Let's just say each one is 1, okay? Make it nice and easy for us. So, x minus 4, 1, 2, 3, 4. Okay, so this is negative 4, and we have a slope of 1. So up 1 over 1, up 1 over 1. Keep going, get some points on there, and now we could draw our line. Okay, and then our other equation, y is equal to x plus 1, so our y-intercept is 1. We start there, and we go up 1 over 1, up 1 over 1, up 1 over 1. And we could go down 1 to the left 1 as well. So there's my two lines. You know, we can't see if they intersect on this graph. Maybe they intersect as the lines go off the graph, but these look pretty straight. Like they look like they're going in the same direction. And so for this one, these lines are actually parallel. You can see they have the same slope, right? They're never going to touch because if this one goes to right, it's also going up to right, up. They have that same pattern that they're following. So they kind of stay in their own lane. So these are parallel lines, which means they never intersect, which means they have no solutions. So that's our answer, no solutions. All right, let's look at another one. We have y is equal to half x plus 3, and then we need to write this in slope-intercept form. So we're going to begin by getting y by itself. So we have to add 3x. So we get 6y is equal to 3x plus 18. Then we need to divide by 6. So y is equal 3 divided by 6 is a half x. 18 divided by 6 is 3. So there's our two equations. So let's start with our first one. Y is equal to a half x plus 3. My y-intercept is 3. My slope is a half. So I go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, or down 1 over 2. And so now I can draw my line nice and straight. There we go. If we look at my next one, y is equal to a half x plus 3. So I start at my y-intercept 3, go up 1 over 1, up 1 over 1, up 1, or sorry, over 2, up 1 over 2, down 1 over 2, and guess what? They're the exact same line because the equations are exactly the same. So, if they're the same line, then they always intersect. Every single point is the same for them. And so there's infinite solutions. And there's our solution for that one. All right, guys, good luck on the practice. You got it. And have a great weekend. Bye.